loading. Good afternoon. How's
Morning to
everybody
some
doing?
people. Morning to some still.
Well,
right?
yes, okay, let me rephrase that. Good morning to some people. Morning to some people. Sounds odd. I'm a little shell shocked anyway. I'm not going to lie here. So anyway, we'll start that over again. Good afternoon. I'm Bob Krell from the host of Healthy Indoor Show, which you are joining us live right now. With us today, we first of all, let me preface this by saying I just came off the air from 4 consecutive days of live streaming all day. So if I'm a little punch drunk, that's my excuse, and I'm going to stick with it. No way around it. But anyway, we have a great show today. We're getting out of our normal format a little bit, which is, I think, okay. Last time we wanted to see how many people we could get on a screen at one time. Today, we actually have one featured guest, so this will be great. So Nikki Kruger is here with us today. And this is going to be a little departure from our COVID-19 stuff we've been doing lately. We're going to be talking about other indoor air quality issues. Imagine that. I recognize the pandemic's not over. Don't think for 1 minute that we're discounting that we're still in crisis mode in the U.S. But as we've been mentioning from all along on our shows, the other issues, the other problems that we are experiencing and that we have always experienced in our indoor environments, such as moisture problems and mold and a whole plethora of other great things, well, they're still there. The pandemic hasn't gotten rid of any of that for us. So today we're going to do a little bit of a shift off because we're spending more time in our indoor environment, right? A lot of us are still quarantined in a lot of these states, staying at home. Many people are telecommuting. So our indoor environments in our living spaces where we may be spending more time than typical is going to be very important. So to that end, our guest today is Nikki Kruger. She's the building science manager for Thermistor's residential and light commercial moisture control product lines, including the Ultra Air whole house ventilating dehumidifiers and Santa Fe freestanding dehumidifiers. She's been involved in the indoor air quality industry for over 15 years. She's a ResNet certified home Energy Star rater, a member of the ACA Manual Low Load Homes Advisory Committee, and recently completed the ACA certification. So with that, I guess, welcome, Nikki.
Thank you.
And of course, I'm joined as always by our co-pilot, chief provocateur, the healthy building scientist from Hayward Score, Mr. Joe Medosh, live from Colorado.
Thanks for being here.
Nikki's from Minnesota right now, so we're at least nationwide, baby.
Wisconsin. Let's.
Why did I do that?
Wisconsin.
I don't know. I'm actually in Virginia, but we're headquartered in Wisconsin. So.
Okay. Well, now that I've been schooled, because once again, and I've been mentioning that I've been doing Ron Burgundy moments. Once again, I've just done another Ron Burgundy moment because I walked off the teleprompter, and so be it. So, welcome.
Thank you very much.
So I guess precursor, or maybe the overall question, why we got to be worried about this stuff? I mean, is moisture really a big problem? Because I know with all the COVID-19 recommendations, or at least some of the recommendations are saying, hey, raise the humidity in your house, you'll lower your chance of virus exposure and viral infection.
And I think, just like any recommendation that's being put out there right now, you have to be very careful because looking at one specific thing and trying to create an environment to prevent that could create a whole host of other problems, right? I mean, no good deed goes unpunished. So just like we tighten our homes and we've got to look at other things because saving energy is a good thing, but on the opposite end, no good deed goes unpunished and we create other problems. So I think we need a range, and I think we need to look at who is in that home and then decide what the most appropriate strategies are for creating a healthy indoor environment based on who is in that home.
Well, but homes are not like hospitals or commercial environments where they can, within a matter of minutes, say, you know what? Let's reduce the humidity. Oh, let's change the temperature. Let's bring in more outside air due to everybody's having higher carbon dioxide levels. So our homes are not well engineered to make those kind of adjustments, they could take hours or days to try to like, make those kind of tweaks. So there is a serious challenge at homes when people are like, oh, just adjust your humidity. And I'm like, and how? So, yeah.
Well, let's first of all look at what we're doing in our homes, because there are simple things that people can do to immediately affect their indoor environments, right? I mean, I think everybody's cleaning a lot, washing their hands a lot, using stuff maybe that's got more chemicals that are doing harm when they think they're doing something that's good. We have more people in the house. Do we open up our windows? Now, I know that opening up our windows oftentimes is a recommendation, but here in Virginia, we were just covered in yellow pollen the other day. So if you have allergies, the last thing you want to do is, open up your windows. So again, there's challenges based on who's living in your home, but
we have a couple of recommendations for that. We've been promoting open your windows, and people say that's so there's two things. You could open up you can just turn on the exhaust fans, which just bring air in through your house. It has a natural MERV 13 kind of filtration.
I think if you're in an environment that's not humid out, exhaust ventilation is okay.
Not 24/7, right? Again, just for a little while. Yeah.
Yeah. But if you're in a humid environment with high dew points outside, and you turn on that exhaust, I mean, 1 CFM out is 1 CFM in, and you're going to be sucking in that humid air and not knowing where it's coming from. I mean, hopefully it's filtered.
No, yeah, your house is filtering it. Yeah, I got it.
Yeah. You just never know. So that is with a lot of builders and developers in the mid-Atlantic and in the South, that is when I get calls that we're having moisture issues in our homes or a homeowner. The first thing that I always ask is, what is your ventilation strategy? First of all, is there a ventilation strategy? And if there is, what it is. And it seems to be that everybody's going to exhaust only in these humid, mixed humid climates. And so one large developer, I went in and there's mold in all these townhouses. And I'm like, the first thing we have to do is shut off the third floor bathroom exhaust that's running continuous. Because we just measured and it's sucking in air through the bath fan on the first floor. And it's entering, and there's a supply vent, a register in that bathroom, and we're raining in that bathroom. And he's like, well, Energy Star requires us to ventilate.
That's the problem, right? Because ASHRAE makes recommendations of using bathroom fans for actually doing air changes in buildings.
Well, and I said yes, they do require you to ventilate, but you chose the cheapest option.
Yes.
And not the right one for our climate. And I think that's what we're going to see just with some of the ASHRAE talks and stuff is, we have exhaust supply, balanced ventilation recommendations. But I think we really need to look at, depending on your climate zone, which ones are appropriate for those climate zones. Because exhaust is getting us into a lot of troubles in the more humid climates for sure. So I think that's one thing to look at, especially if you're in one of those climate zones that you have a lot of moisture and you're concerned about humidity, concerned about, sucking things out. Because I don't think a lot of people understand because you're removing doesn't mean that it's not coming back in from somewhere. And then you got to think about what you're bringing in and where you're bringing it in from.
Yeah, I taught a bunch of contractors in Florida when they went to their blower door testing.
Yep.
And the blower door at a certain point, once it gets tight, you must bring in mechanical ventilation. The responses were shocking. They were like, can't I just cut a hole in the wall with a damper? Can I just cut more holes? And these are the top questions I got, not like how to install ventilation. It was like, can I just cut more holes in the top plate? What can I do they're like, well, if I make the home leakier, then I won't have to do any of this other stuff. So, yeah. Yeah,
that's true. Well, and it's funny that you bring that up because I was just recently looking at some articles that were done about Florida and their ventilation amendment to their building code. So in Florida, you don't have to do mechanical ventilation until you reach 3 ACH 50. And
But that's actually easy. They thought that would be difficult to do, but they're foam and everything. As soon as you foam the attic and and their walls. Yeah.
Okay, but that's another issue which we'll take as a sidebar too.
Yeah.
Well, and I think, it's almost like you're rewarded for not getting tighter because they don't want to do mechanical ventilation, right? So it's like, okay, can we just get close enough? But Mike Moore wrote an article for HVI when Florida was thinking about this. And basically it said in homes in Florida that are at 3 ACH 50 with no mechanical ventilation, their formaldehyde rates will be 40% higher in those homes.
Wow.
Than homes that are being mechanically ventilated. So, I mean, formaldehyde is a big thing that most people don't think about in their homes, but all of our products pretty much that you bring in, all your IKEA stuff, all that is.
Yeah, anything that's a laminate,
It is.
it's pretty much filled with it. Yeah.
Yeah,
but
off-gassing.
most people don't understand that formaldehyde is hydrophilic, which means that it responds higher with moisture in general.
Yes.
So that's the key that people are like, well, I've had it for years. I'm like, well, it still is off-gassing, and if you have higher humidity, it's off-gassing even more.
Yeah. And that's why I always give this example is the Chinese drywall. They know it made it farther north than Florida. But because they didn't have the amount of humidity for the extended period of time that they were seeing in Florida, it was harder to track it.
Wow.
So,
Yeah, right. Well, because you had catastrophic events down in those humid in the Gulf Coast, where all electrical components were all failing,
yeah.
right? And shorting out, burning down buildings,
Corroding,
yeah, just all kinds of horrible things.
And
Our buddy Sean McCumber was big on that. Still is, by the way. Still,
and that's where I
heavily
first
embedded in
met
that.
Sean. Actually, Ken Gehring, the gentleman who invented the whole Ultra Air in Santa Fe's, he was doing a bunch of testing down there with dehumidifiers and figured out that they could stop or not stop, but reduce the amount of corrosion. But the thing is nobody still wanted to live in a house that was the potential, right? As a mother with 2 kids, and I have a daughter with asthma, you couldn't tell me, well, we can put kind of reduce the amount of off-gassing by using a dehumidifier. That wasn't really an option for most people.
And that probably the corrosion thing, certainly wasn't the primary driving factor though for dehumidification, right? You're not suggesting that.
No.
Okay.
I mean, it
Just
was the
it's an
chemicals
added
that were
benefit.
inside, but they could reduce the rate of which it was off-gassing if
Got
they
it.
used the dehumidifier. But no, nobody, we didn't want that as the fix, but we figured, that was something that we figured out what was causing it there versus as it headed up north more. So.
Mhm.
Well, I think your underlying point there is that I don't think people understand how much. I mean, we know home is a system, but sometimes that's really always hard to digest or keep track of. You're like, well, it's this thing, and you're like, well, it's a lot of things. So it's not always so easy to just be like, oh, do this and then you're okay. You're like, well, no, there's other ways to accomplish that. Or as soon as you do one thing, you impacted another.
Well, and I was having a really interesting conversation yesterday, actually. When I was talking about being on this program and ventilation and dehumidification. And what's really interesting to me is, ventilation is a topic that is very controversial because everybody knows we need some amount of clean indoor air, but nobody knows what that rate is. So there's a lot of controversy of, do we use the ASHRAE? ASHRAE is too much. What do we use? The funny thing to me is we know exactly what our relative humidity level should be, yet we're trying to use a system in the house that really wasn't designed specifically to hit a specific RH. It's really designed to get to a temperature. And as a byproduct, we remove moisture. And we design systems for a specific RH, but that's a peak load condition, which means 1% of the year, you're guaranteed that design of your air conditioning system is going to hopefully get you to that 50%. But then all the other times of the year, we're trying to figure out how to overcool to dehumidify.
Well, I mean, that's a fundamental problem with, many mechanical designs, and I use that term loosely in the residential market, right? Because for years, and I think there's still some contractors, mechanical contractors, that will oversize cooling. Well, if it calls for 2.5 tons, 3 tons is better, right? But it's not.
Yeah, and it's the software oversizes automatically, and then the contractor also oversizes on that. So you could be 30% oversized.
Joe's showing us a lot of pictures on his screen. It's like,
Oh.
I'm losing my mind here.
Sorry. I picked the wrong one.
This is his
Sorry.
John Nash impression. He has
Wow,
a beautiful
whoops.
mind.
Yeah,
It's
right.
like, I don't see any red yarn tying the pieces together.
Sorry.
but
I was trying to share the one slide.
Well, you shared something.
I did, right?
You shared a look into your life. Okay.
Yeah, so there's our recommendations of where we should be. And really 50%, I think that 50% mark for your cooling season is ideal for health. If we look at this, that's what's ideal for health. So if you're designing a system based on health, that 50% is ideal. 30% is winter time. So if you can get to 30% in a heating dominated climate by using a humidifier, you'll be lucky. I mean, my house in Wisconsin was an old leaky house, and I couldn't get, even with a humidifier, I couldn't get to 30% in that house. But 50 in the shoulder seasons, and when it's humid out, and in the summer is ideal. Now, those shoulder seasons are really the time that, we have a lot of allergens in the air, typically lots of stuff blooming, molds, tree pollens, all that kind of stuff. And so dew points are usually high. If we go to the dew point map that I sent you that has March, I think it's March 18th on it.
Working on it.
Okay. Actually, that was the day that I did an interview with Brian Orr on his podcast. And I pulled up the dew point maps just to kind of see what was going on. And, there was a large part of the South and the Southeast where dew points were on average 68 degrees and temperatures were about 70. So,
There you go.
Yeah.
Yeah.
Focusing.
So to describe what we're looking at, Nikki, because it's there's a lot going on there. So tell us about.
Well, I'm seeing your whole screen.
Yeah,
what?
we are seeing your whole screen again, Joe.
I'm not sorry. I apologize. I'm not picking that.
And in Joe Madosh's defense, and in his defense right now, he and I have been going literally nonstop all week without any sleep.
Okay.
For the home performance conference that's currently live streaming.
So
there you go.
Every day I check the dew point maps, just kind of see where we're at. And Ken Gehring is the guy who definitely got me looking at this, as he shared stuff all the time. And I think we have another one we can look at. But on March 18th, on that upper left-hand slide, you can see where, anytime you're above a 55-degree dew point, which is kind of what ASHRAE recommends for inside of our house for comfort. When we start getting above that 55-degree dew point, we're going to start getting uncomfortable. So obviously there was a large part of the country. Now this one Ken sent to me, and this was late last September, so September 25th. And what's interesting about this is a lot of times when I talk about dehumidifiers, especially whole house, they're like, oh, if you live in Florida, you probably need one of those. Well, if you live in a leakier house in Florida, probably your air conditioning is going to be running. Oh, can we go back to that quick?
Oh, yeah, sure. Sorry.
Your air conditioning is going to be running a lot more. So I just bought a house in Virginia. My RH in my house last July was 33%. And that's because I have a super leaky house and my air conditioner never shut off. But you can see dew points down in Florida, 70 up in the northern part is what we have in Maine. We have 70-degree dew points. So if you look on the left side hand of that slide, if you're bringing in 100 CFM of fresh air, you got 1 to 6 pints of dehumidification needed an hour. In late September in Maine, you're probably not running very much air conditioning in
So
a large part of the country.
you are using two metrics. So I would just like for you to just pause for a second and
Yes.
talk about RH, relative humidity, versus
Sure.
dew point, so people understand, because dew point is suddenly now becoming a building science regular term, and it's ASHRAE is now embraced it and put it into their standard. So why don't you explain the dew point concept
Sure.
versus
So
relative
dew
humidity?
point is the absolute measurement of moisture in the air. So it's more of an absolute. So when we hit, let's say it's 72 degrees and it's a 72-degree dew point, we're raining. The air can't hold any more water, and that's 100% relative humidity. So relative humidity is always relative to the temperature. So dew point is really gives us a better idea of how much moisture is actually in the air.
I mean, it's the temperature, the surface temperature or air temperature at which
Yeah.
Water vapor is going to condense and become a
Yes.
liquid on the surface.
Yeah. And, we briefly brought up before that talking about crawl spaces. I mean, dew points are really important in our crawl spaces, in our attics, anywhere that our ductwork's going to be, and we need to insulate it and insulate it properly. But yeah, this is called DP Calc. And so if it's dpcalc.org, you can find this, but I just put in that 68-degree dew point and a 72-degree temperature. And if you go on the right-hand side here, I'll tell you your mold risk, you have 5 days till mold. So it's a great resource to use. I think this was designed for self-storage.
Yeah, but I can tell you that everybody in the industry lives by this actual site. This is one of the most accurate sites and most well referenced sites in terms of calculating dew point.
Yep.
And we'll get that up in the chat, by the way, too, that link to that. And just so everybody knows too, Nikki, we'll be sharing some of your slides after, up on our site along with the recording. So, because we had some questions in chat, whether they'd be able to get some of these graphics. So we'll get some of that up there.
Absolutely. So, and I do think, crawl spaces in basements and houses built on slabs, what we call green grass climates. So anywhere that you're getting an inch of rain or more a week during the spring, summer, and fall, where you have green grass, you're going to need dehumidification at some point. Some places you might need it longer, some places you might need it shorter, but there's challenges for all those different homes built on those foundations. So a crawl space, if it's vented, don't vent it. I think the statistics are there's about 70,000 homes in the Southeast built on crawl spaces every year. There's an estimated 26 million homes with crawl spaces. And now we are learning the building science of how to encapsulate those and encapsulate them correctly, because there really isn't any formal guidance on encapsulating those. We worked with, several building science experts, Joe Steenbrook, Allison Bales, and came up with a 2-day encapsulation course with advanced energy. And it really is the building science behind it. And we talk about dehumidifiers as part of it, but it's really the building science, because as soon as you change where your building envelope is, you've changed the whole house. And if you do a half job, you will screw it up more, and you're better off probably just leaving it.
Let's just go back and make sure that we clarify some of these points, because again, we have a broad audience here, so we have a lot of professionals. We also have consumers on the show too, or watching the show. So the term building envelope, that term is the 6 sides, right? If your building is a box, there's 6 sides to that box, right? So the building envelope is really what keeps the outdoors from the indoors.
Yep.
Right, in the simplest terms. So it's it's that delineation point.
Well, no, wait. I'm going to clarify that before you move past. Is that most people don't think that their crawl space is part of their envelope or their shell, or is included in their house, because they think, oh, that's outside of that. And ironically, so did the indoor air quality collectives and a variety. People don't think that their attic is actually connected. And so when I first started, people were like, "Oh, you have issues down the crawl space, but who cares? It's not part of the conditioned space." And I'm like, "Well, it is." And if somebody shows up with a blower door, yeah.
Well,
And
yeah, well, that's the
50%.
thing. It's not supposed to, well, it depends, right? If you were going to have a ventilated crawl space, then it's supposed to be completely physically, thermally, and pressure boundary detached from the house. If your house is up on stilts, that crawl space is really outdoors.
That's correct.
But that's usually not the case.
That's very rare. That there aren't many people
Yeah.
that have that. So, but most people don't think that their crawl space is connected to, what they're actually breathing, and that's a shocker to find that out.
Well, I went down in Louisiana to Sean McComer's house, and FEMA came in and gave everybody a bunch of money to raise their homes. And as soon as the building inspector signed off on it, they all enclosed those spaces underneath and then made them part of the building envelope because it was extra storage, extra room. And a lot of people store stuff in their crawl spaces.
And that's going to be great during the next hurricane.
Yeah, exactly. Well, 50% of the air in your living space comes from below the home. So
50. I want to make sure we got that. It was 50, right?
50. Yep. So, I mean, that's a lot of air. And there's a lot of moisture. I mean, Justin Wilson from Construction Instruction often talks about how basically a basement or a crawl space is basically you've built part of your house as an indoor pool.
And moisture goes from more to less. So again, back to the building science. So your high moisture load below your house wants to go to where it's drier, and it will move right through those materials and all of those air gaps.
Yeah. So it's very important. And we have different strategies in building code in order to, let's also clarify, encapsulated crawl space is also a closed crawl space, because I think in building code, it refers to it as a closed crawl space. But I do have a slide, that I sent you. I think it's the last one there, that you can use supply air from your HVAC system to, by code, condition your crawl space. So the data that I had sent you, we took here in Northern Virginia, we took two Habitat houses, the exact same houses, built right next door to each other. And we knew the building standard they were built to. We had all the blower door, everything, and encapsulated them. And one we used supply air, and in the other one we used a dehumidifier. And I had to shut off the alerts on the monitoring equipment on the supply air one because it was above 70% basically from spring to fall. Because you're counting on people to run their air conditioning enough to put drier, colder air into a cold space already in order to condition it, which really a crawl space, the only thing you want to condition is the relative humidity. You just want to keep it so you're not getting high relative humidity or creating condensation issues. And in the other one, we used a dehumidifier and just kept it, set exactly at 50%. And that's what it was at. And that's, I think, the biggest takeaway when I talk to builders and contractors and homeowners is, what do you want your relative humidity to be in the humid seasons at all time?
I think one of the things I talked to many contractors and they talk about what feels good for the occupant is a easier way to manage that versus a number. That's always kind of the challenge as to, well, I think it should be, and then they get frustrated because it's 3 off from the number that they were trying to achieve. So what's your recommendation for the comfort zone, not necessarily maybe a number that they think is the best?
Yeah, I mean, people do definitely get caught up on what that number is. And as soon as it's not that number, they're angry at somebody. But the reality is the only way to actually get close to that number is putting in a device that actually is going to focus on getting to that number.
And that's really because, right, I mean, I think consumers assume that their air conditioning really is, there to dehumidify and cool, but that's really not the case. It's that AC is for sensible cooling. It's really, latent moisture removal is just like kind of an added benefit that it does while the system's running, right? But once you hit your cool temperature that you're seeking for your air conditioning, it shuts off.
Yeah,
So you can't really dehumidify
well,
with
that's
it.
exactly, so if we look at this on the right-hand side, this was in late April, early May, and this is where we're using supply air to try to deliver, dry air to a crawl space in order to condition it. And it's consistently above 70%. And on the left-hand side, this is the house next door, and we used a dehumidifier. We set it a little lower because this was new construction, and we know we're going to have a lot of construction moisture in the beginning. And they had, which I think happens quite a bit, because they closed up these houses in spring, they already had to remediate that crawl space for mold before the people actually moved in. So we really wanted to make sure, but we just set the dehumidifier, and that way we can always keep it at close to a set relative humidity and protect it. So I think monitoring is important. A lot of times people are like, well, do I need a crawl space dehumidifier? Do I need a whole house dehumidifier? Do I just need a basement? What do I need? And first of all, what are your goals? If you want to just do property protection in the crawl space, we don't have anybody in the house that's, maybe there's some respiratory issues, but let's put in one in the crawl space, monitor the living space, and maybe just by removing that moisture in the crawl space, we've alleviated the problem in the living space. But, some houses are going to need a crawl space and a whole house ventilating dehumidifier. And the nice thing about a ventilating dehumidifier is you actually can meet your code requirement for your ventilation, mechanical ventilation. It has MERV 13 filtration, and you can dehumidify the entire home separate from the air conditioner. So this is kind of what we talked about when we look at, sizing our HVAC equipment according to best practices. And that left-hand corner up there, I would say 78 degrees for an indoor cooling temp is probably a little high. That's what Florida Solar Energy would like you to keep it at. But the reality is it's probably—
That's kind of stuffy.
Yeah. Well, it shouldn't be at 50% relative humidity, but this is peak load, right? So you probably can be pretty comfortable, which people don't understand. You can increase your thermostat setting and feel just as comfortable 2 to 3 degrees if you keep that relative humidity in check. So it's a difference between summer in Miami and summer in Arizona, right? You can handle the higher temperatures in Arizona because you don't have that humidity as much. But if we look at the numbers down here, and again, this is your total cooling, and it breaks it out into the sensible. The sensible is that temperature of what we feel, and the latent is the moisture. And the reality is our sensible and latent loads are becoming closer and closer in numbers. There's not that drastic as it used to be because our homes are getting tighter and tighter. So we don't have the sensible loads that we used to because we're doing such a good job with, high efficiency windows and doors, and with our envelopes and, caulking or spray foaming or whatever that may be to stop the outdoors from coming in, which means we don't have the cooling loads we used to, but our moisture loads are staying the same or possibly going up because now we are bringing in that outdoor air.
Well, the other thing is that, and people forget that they are a huge load of moisture in the house, and
some more than others.
Yeah.
And that's there's the problem. So there's a couple of audience questions here, and I just want to grab one of them. This going back to your crawl space comment. At what percentage relative humidity in a crawl space will it impact the comfort level in the room above it? I guess that's kind of a loaded question because it really depends on the construction of the building and the leakage.
And that's the challenge. I even had a production builder reach out the other day and said, your spec sheet says that you recommend this dehumidifier up to a certain square footage of house. And we have a mechanical engineer that is challenging that. He doesn't want to put in the smaller dehumidifier because it's a larger square footage. And so there are so many variables that is a recommendation because I don't know how leaky your house is. I don't know how many people are in your house. I don't know what your activities are. So it really depends. I think if you keep the crawl space at 55%, that should help mitigate if the crawl space is the issue, moisture is the issue from the crawl space. But it's going to depend on what's going on upstairs if you're going to need an additional dehumidification for
Wait,
the rest of the house.
I want to go on record that, Advanced Energy out of North Carolina, which has a lot of crawl spaces, they were leading the charge on here's why these things are not good in terms of how moisture comes in and doesn't leave and what it's doing to the house. And yet nobody really accepted that this was a change. It took forever for the code to just say it's okay to seal these things up. And like, we don't understand that there's a strategy for the crawl space, not just what should it be down there, but how is it vented? How is it connected to the house? Is it not connected to the house? How are you dehumidifying it? If you don't have that strategy, you can't just say, get a dehumidifier and it will solve the problem.
No.
You must understand how it's connected to outside and inside.
And you've got to close up those holes and all that communication. And, North Carolina is the only state that's had dehumidifiers in their code forever on how to condition a crawl. And so about 4 years ago, I worked with Joe Steenbrook on getting dehumidifiers into the IRC code because it wasn't in there. And really the only thing you want to do is control the relative humidity or the moisture in the crawl space. I mean, that's,
raises a question for me too. And we've got another question coming in, but prior to reading that, and this has been one of my bones of contention. A lot of ASHRAE always there's always this I think this reverse extrapolation. Obviously, if your moisture content, your MC on a building material is over 0.7, right? So that you actually are more than 70% relative humidity on a surface, the likelihood of microbial growth definitely increases, right? No question about that. But I see this over and over where there's this number that's saying, well, if you keep your building below 60% relative humidity, you decrease the likelihood of mold in the building. It can't happen, and that's just so erroneous. Because the mold's not growing in the air; it's growing on surfaces, and you can still have thermal bridging and condensation. You're hitting dew point. I mean, I've seen this so much in the north, and you've lived in the north. You're in the heating season here in New York State. You're so dry in the house. It's 25%, 20% relative humidity in the house, but you could still have saturated walls, just due to the building envelope failures, and you could have mold growing in the wall cavities.
Yeah,
while it's so dry, you're bleeding out of your nose.
Yeah, and it's relative. So we need to know dew points. That's what we need to know.
Wait, I want to interject one more challenge. So how do you measure relative humidity? And that's Kevin Kennedy and I, we debate this a lot. So we have the concept that it's not one measurement for the house. It's not even one measurement for the room. So if you really want to do an assessment about the relative humidity, you need to know what time and what season you're doing that. And that usually you should be a collection of multiple readings in multiple rooms to give you just kind of a snapshot as to here's what's happening now. But people think that, well, my thermostat says the relative humidity is this, but your basement and your upper floors are completely another world.
We're talking moisture mapping here too, as opposed to a single point like where your thermostat is. You're saying that's your relative humidity? No, it's your relative humidity at your thermostat. That's all right. That is.
Right.
Yeah. Well, and that's why, like for crawl spaces, our crawl space dehumidifiers, we have dual exhaust on a lot of them. So, and even our smallest one that does it, we recommend putting some flex duct, especially on the exhaust side, the supply side, to get that dry air away from the dehumidifier and more out to the farthest corners. Because that's where you risk condensation the most, is in those corner areas. So if you just put a dehumidifier down there in a small space, what happens is you're creating a microclimate, right? It's just that sensor inside of it starts reading the dry air coming out of it in the space around that dehumidifier. So we really want to try to get the dry air that's coming out of it away from it to the farther corners, because we're reading the relative humidity in that, right where that dehumidifier.
We're trying to get mixing. I mean, that's true with any air principle. Air filtering is the same principle. You're only, if you have a short cycle.
Yep. So, and that's, I think with, a ducted dehumidifier, it's the same thing, right? Like we know that we do a lot of multifamily work with our in-wall dehumidifier. So you put this in-wall dehumidifier in a central location. Well, if they're not keeping the doors open in the bedrooms, or there's not an undercut on the door or a transfer grill, then obviously we can still have a lot of problems in the rooms that are farther away with doors closed. So we really have to educate that, you got to keep doors open, or for sure, you're going to put those transfer grills in to get more communication with that dehumidifier.
Let's explain, make sure we understand what a transfer grill is. So you're talking about, it looks like a supply or exhaust vent in your usually ceiling, could be even on the door or on the wall, but the goal is it's now jumping over the wall, right? And has another duct. So it just really is only communicating with itself to allow air to move, whether your door's open or closed.
Exactly. And we've seen them even put grills right in the doors.
Yeah.
Yeah, I mean, it's effectively like an undercut on a door. It's serving
Yeah.
the same purpose to
Yes.
allow air transfer between rooms.
Yeah. And I think, one area of growth that we have definitely seen the need for dehumidification is in multifamily apartments, because we're getting tighter and tighter on those. They are required to have typically some sort of ventilation, and all the HVAC systems are oversized for the units. So we've got a couple properties here in Virginia where they put in 2-stage equipment on 800 square feet to try to control the humidity, because that's what they were sold as. So you're looking at 2 tons of AC on 800 square feet. So it's going to come on and cool, and it's
Instantly.
it's just going to keep cooling. And so the one apartment we went into, the resident had it at 66 degrees because she was uncomfortable. And that control station on my wall is all I know, right? Up or down. I'm uncomfortable. So that's what's supposed to keep me comfortable. So I'm going up or down, and she kept going down. And, when the temperature goes down, the relative humidity goes up.
Well, she's also creating a thermal plane inside of that ductwork and stuff to start having liquid water accumulating in the ductwork. Now you're going to have subsequent microbial growth there.
And then within a week, in about a complex of 20 apartments, there was 5 of them that were completely covered in mold. So
Yeah, let's talk about the short cycling, because you implied that, but I don't think people understand that when it comes on and it cools quickly, that's not a good thing, because it did not remove the humidity. That its goal is to actually remove the heat, right, which cools the house. But while it's running, it's all of this liquid that runs out of that PVC pipe outside, that is removing your humidity. And when it's on quick and gone, humidity stayed. So that's so they lower the temperature to be like, oh, it's keeps shutting off. I need to lower the temperature. And now, it's
a death spiral.
20 minutes of runtime before a drop of water starts going down the drain. I think ASHRAE has a chart. It says 14 minutes to effective dehumidification, which means you're going to possibly start getting water dripping down the drain. So Anthony Cox, I don't know if you guys know, I think, Joe, you probably know Anthony. He's a building science gentleman that monitored a bunch of apartments, and I think it was in Alabama, but I don't know the total number, but it was a large number of apartments during the summer, and the average runtime was 7 minutes on the air conditioning systems.
It also impacts the coil, because you put moisture on your coil and then it stopped, and you put moisture on your coil and it stops. So there's, again, one thing does not always be straightforward. There's so many things that humidity is a major challenge. So we're glad to have you in, promoting and getting people on the same page as to why humidity is not just a comfort issue, it's a building science issue.
A lot of times it's, moisture is the number one detriment to a building and our health and our comfort. But whenever people talk about indoor air quality, they automatically go to ventilation and filtration. Relative humidity isn't often thought about. It's because we're assuming that the air conditioner is going to take care of it. And it gets dry in the winter, so I'll use a portable, humidifier. Or if you are from the Northeast or Midwest, we all grew up with dehumidifiers in our basements, because we needed them in the basements, and we knew that. But the reality is our houses are getting so tight now, even code. So we talked about, you had mentioned I was on that low load homes manual committee for ACA. And basically that new manual assumes you know Manual J,
Right.
Manual
And doing it
FN,
and doing it. And you not just know it. I have
And
the
you're
book on the
doing it.
shelf. Right.
and
Yeah.
then you take those concepts and now we're going to apply them to a low load home. Well, what's a low load home? So basically, if you are building 2012 to 2015 code or newer, you're building a low load home. And a lot of builders, they don't associate themselves with building a high performance or low load home. They're building a code home.
No load, to make sure we all talk. It means you don't need to use your heating and cooling as much as other homes in the past.
Yeah, and stress the point about code
load.
homes too, Nikki.
What?
What is a code home? It's the lowest denomination, lowest standard you can build to before
Legally
it fails.
built to.
That's slightly above failure. That's what that is.
But a lot of states have really jumped to 2000 and 2018 code in the last couple of years, and it is a big change for the contractors working on them and the builders building them, because they are dealing with moisture issues that they've never dealt with before. Because as long as we wet and dry, we're typically okay. The problem is now our houses are wetting, and we don't have that drying mechanism anymore.
Well, the one thing that's impacted us, because the code again is the minimum, but it finally said, okay, test the house. And once we started doing blower door tests and you now knew that you had failed and you had to fix that. Now we, for the first time, had, yes, this is a confirmed tight house. And that is what's kind of pushed us over the edge to be like, okay, prior we were like, you were allowed to walk around and determine that it was a tight house by looking at it, which was pretty scary in itself. That's not even, but now you are testing and you are fixing it. And so builders are doing them, as well as all of the foam. Foam is an instant tight house.
Yeah. Well, and a lot of people and a lot of contractors challenge me on variable speed equipment. Well, you don't need a dehumidifier if you're using variable speed. The reality is one speed of variable is off. So if it's 70 and raining and somebody walks by a register that's spitting out cold air, they're going to shut it off. And still, in order for that variable speed to work, you have to have a load. So it can't just keep overcooling to dehumidify, because if it does that, then we're going to definitely get into condensation issues and comfort issues. So you still have to have a load and for that variable speed to work. And then you throw in people who are supposed to be managing and understanding how that all works together. It can be very risky.
Well, a consumer's not going to know that. Nate Adams has a question here. I want to bring this in.
Of course, Nate does.
Yeah, of course. Hi, Nate. So, and Nate is a very well-versed guy who is also one of our contributing editors for Healthy Indoors magazine. So, the question is, can you comment on the 40 to 60% relative humidity recommendation for viruses? What about winter durability?
Yeah. See, I'm
We're getting
not
back to
comment
COVID. There's
too
no
much.
way getting away from it.
Yeah, I mean, that's my house in Wisconsin. I mean, it was built in the 1870s, and it had been updated, but still, it was a leak. I mean, it was a leaky house. And if I could get close to 20% with using a humidifier, I was lucky. So for that 40% really kind of scares me. If people try to do that.
Well, I'll try and chime in as to why that recommendation has been out. That there was a study done with hospitals. It was a pretty expansive study that talked about just flu viruses, and they tracked thousands of things, and they figured out the humidity was the largest thing that determined the transmission. And so when it's more humid, that means that the particles in the air are larger because of the moisture, which means that they're going to heavier, they're fall. Your lungs are better, and viruses have the ability to get into your lungs deeper when your lungs are dry. So that was the basis behind this kind of a concept.
Yeah, but if that was totally the case, then nobody down in the Gulf Coast would be getting COVID-19, so, or influenza, or
Well,
yes.
It's not supposed to prevent it. It's the goal is supposed to reduce transmission.
I know, but there were recommendations at the early stages of this COVID thing saying, increase the humidity in your buildings.
Well, those are coming from mold remediators. Okay, just so we're on the same page, right?
Yeah, but I'm one of those people. I wasn't saying that. That's nonsense.
Wait. There's one thing I want to make sure we touch base because our time is running late. So we talked about consumers. Yeah. So Nikki, can you the one thing that is a missing link about people who want to try and control their humidity is the maintenance. Okay. And it is just the forgotten thing. Like, oh yeah, I got this humidifier down there where my other thing is that I don't know how well it runs. I do change the filter every now and then. Can you talk briefly about maintenance for a whole house dehumidifier, or even the one in your crawl space you're trying to monitor? Yeah.
Sure. So first of all, especially if you're going to be talking about dehumidifiers and crawl spaces, make sure you're putting a dehumidifier in a crawl space that's designed for a crawl space. So a lot of the ones on the market that are coming out of China and have sold a big box aren't really designed to be placed in a crawl space and forgotten about. And they 1 year warranty, and then usually that's about it. And so we really need to be using equipment that's specifically designed for those applications. So filter is always going to be, you're going to have to change a filter. Now, the crawl space one, probably once a year, you're going to be okay. A whole house, if you're using it for ventilation and dehumidification, probably twice a year, maybe 3 times a year, depending on if you have somebody in the house that has respiratory issues and you're a little bit more sensitive. But for sure, I would say typically twice a year for a whole house. And again, we're filtering the air that's coming in. If you're using it for ventilation, you don't have to, but we're also filtering all the air from the house moving to, and MERV 13 filtration is pretty darn good filtration.
It is. Oh, it is. Yeah.
Yeah. And then the condensate line. So anytime that, you know, the HVAC contractor, if you have a maintenance agreement, or the homeowner, just like your air conditioning line, you got to just check that condensate line to make sure that it's not building up anything in there and cleaning it. And that's really all you need to be doing for these pieces. They're mechanical pieces of equipment. They need to be maintained.
Well, I just want to confirm that when you said it, so people think about like, oh, ventilation, it's part of my heating and cooling system, but that doesn't run all the time. And if you're in a mixed climate, you're not using it very often. But those who are in high humid who do a ventilating dehumidifier, that runs a lot. And that actually does a lot of amazing filtration, because when it's run, it can actually filter the things that your HVAC system is not doing. So there are some standalone units that can actually do that. Yes.
Yeah. I mean, when we bring in that outdoor air, and usually it's based on a timer system, right? Like, why ventilate when nobody's home? So set up the ventilation to ventilate when people are home, and we'll filter that air. But the dehumidifier is going to run based on the relative humidity in the house. So if the relative humidity is high, let's say you set it at 50%, it gets above 50%, the dehumidifier comes on. Now, if it's time to ventilate at that time, the damper for the ventilation will open, we'll suck in that air, we'll remove a little bit of that moisture from the outside air, and then we'll deliver it to the house. Now, if it's time for ventilation and the relative humidity inside isn't high, then the fan's just going to turn on from the dehumidifier and bring in that outdoor air. So a lot of people say, well, I want to dehumidify all that ventilation air. Well, the reality is, just like an air conditioner, you got to load up coils for a dehumidifier. So the first 3-5 minutes, we're not removing any moisture anyways. We're warming up that air, and it's going to cost you a lot of money to try to dehumidify a very small amount of air that you're bringing in. Usually 50 to 100 CFM is the fresh air. So the reality is we really care about the relative humidity in the living space, and running the dehumidifier, the compressor in that dehumidifier based on that.
You're thinking you can pick up with your overall systems in the building, be able to accommodate that latent moisture that you're bringing in with that outside air.
Yeah, because it's very different thinking from commercial applications to residential. In commercial, they do that. Such a large amount of air that they're bringing in that they will dehumidify it. But the reality is, for residential, it just doesn't make sense. And dehumidification and ventilation are going to cost you money. A healthy home is going to cost you more money. I think the best quote that I heard was from Joe Steenbrook, who said, "You can't energy conserve your way to dry." But
it's gonna. But there is a cost that shows up on your meter or in some way, but we don't really estimate this cost savings that happen because I'm healthier and I'm not doing other things in life. So there is a cost there.
Yeah, healthcare costs versus energy costs. I mean,
they're hard to quantify, though. They're hard to quantify.
I have a
Yeah.
slide here with some clothing. Can I bring that up? Is there something you want to talk
Oh,
about?
yeah. So that one was that was a multifamily project, 400 square foot apartment, and 2 tons of AC on this little 400 square foot apartment. You walked in, and if that AC was on, the air flying out of that register just blew you over. And this lady, there was mold growing, but she was so excited to show me her clothes drying hangers that she got off of PVC. And after we put in an in-wall dehumidifier, I went back and she was so happy because now her clothes were drying so much faster with that dehumidifier. But again, we can design systems based on, we know approximately how much moisture people put in air, right? Like a quarter pound an hour, family of 4, 2 pounds of moisture, 2 pints or pounds of moisture in the air. A pint's a pound the world around. But we can't design for stuff like that.
No.
Our buildings work when we model them and design them until we put people in them.
Well, and the caution is you shouldn't design for that because the next person doesn't have that.
Nope.
So that's why people ask how many bedrooms plus one is just a common standard that things are based upon.
Yeah. And so we should ventilate when people are home. And I get a lot of pushback on that. Well, I don't want to bring in hot air. I don't want to bring in cold air. I don't want to bring in humid air. Well, we should be putting the systems in place to create a healthy, comfortable environment for when people are in the houses. And
I'll push back on that a little bit, but
I'd push back on that a little bit too, because if you leave things going awry when people aren't in the house, you still have to look at 24/7, 365 days a year control in spaces. I don't think you can leave a building uncontrolled.
Well, that or people get home and like, oh, it's uncomfortable, and they do extremes, right? Oh, yeah, right, yeah, right.
But the ventilation part of it is,
clearly
you can minimize that ventilation when nobody's home, right? And then
minimize, that's right, yes, right.
Minimize. And then when people are home, even if it's a dew point of 72 degrees outside, you still should be bringing in that outdoor air to dilute and change, provide an air change, and then provide the systems on the homes to deal with that moisture, the cooling of that air, or whatever, filtering everything that you need.
We're approaching our time when I usually ask our guests to say, so I'm going to make yours very specific. So I'm going to ask you to give me 1 or 2 suggestions for those who are in the southern climate and those who are in a northern climate who've forgotten that they have an actual humidity challenge. So why don't you
What about the Midwest?
That's northern.
What about the Midwest? Well, if they fit into one of those categories about what's going on in their home, then these will kind of fit. So if it's cold outside and those kind of conditions, well, you're similar to Wisconsin or one of the other ones. So what are your recommendations for these different types of climates?
So you're going to need dehumidification. It's just a matter of for how long of a period you're going to need it. And I would say in the Northeast and then the Midwest, if it's a basement you have, sometimes just putting one in a basement, a dehumidifier in the basement, will help the rest of the house. But the reality is you're running air conditioning a lot less, and you still have the high dew points and a lot of moisture in the air. So a dehumidifier for the whole house, especially if you're doing ventilation, you're probably going to need one at some point as well. But in a humid climate, if you're building tighter in the South or the Southeast, and you're not getting the run times on the air conditioning at peak loads, as long as you need, you're going to need a whole house dehumidifier. And it used to be, we worked with a lot of custom builders because they really understood it and would pay for it. And the number of production builders that we've been working with in the last couple of years has really increased tremendously, because I think we're all seeing how tight we're getting, and we just don't have the runtime on the AC. And we can't count on people living in those houses to run those systems the way that they were designed.
And you're seeing the mold issues. When you look at all the builder publications, I mean, mold is always coming up in the top 10, if not the top 5, as a concern for builders, right, nationwide. And
a large part of it is because they were sold that the air conditioner can run in 2-speed or variable speed, and it's going to remove more moisture. But the reality is we're getting these higher energy efficient equipment with the higher sensible heat ratios, meaning it does a really good job getting to that sensible temperature, but it's doing a really horrible job getting that water removal because it's focusing on that energy efficiency. So there's just a lot of confusion with how these air conditioners really are removing more water, and if they truly are.
I appreciate all that you have done for this part of the industry, which has kind of been forgotten about. So I know you're on LinkedIn, you're very active. Are you also a Twitter person?
Not
Yeah,
as
I'm not
much.
either.
I mean,
Yeah.
I am
You
because
don't do the
Nate,
Twitter?
because
Yeah.
Nate Adams, I noticed, tags me, so then I always make sure to check. But not as much. I should be more. Definitely.
Well, my goal is to encourage people to reach out to you because you have a wealth of information. You're
thank you.
gracious about sharing it, and it's all solid information. So if you want to learn more, there's a way to track Nikki down, and she'll answer your question.
Absolutely.
And I would say, Nikki, kudos to showing your professional expertise and chops in a male-dominated industry. Because honest to God, it's like you go out there, and I wouldn't be surprised if people dismiss you initially and are very surprised, because you really do know your stuff. And I think that you're maybe the new wave of the paradigm shift in the industry. Hopefully, that there's more and more of this because, just
Thank you.
because
I've had
white men
great
dominating the
mentors
world,
that help.
it's getting old. It's getting old. On that note, oh boy, I do this, right? It's like I have this tendency to want to throw roll a hand grenade into a room right at the end of the event. Figuratively, of course.
And then you can say cut and walk away.
I do. I walk away and cut the chat line. You were done. So, Joe, final thoughts.
That humidity impacts us as much as anything else we think about in the house in terms of particulates, ventilation, all those things are it is an equal part of the whatever triangle you want to put together. So don't let humidity just go astray.
Yeah, I mean, and I think I'd add to that I think especially now, I think we have to start being more conscious of our indoor environments. We're spending a lot of time in them. And not just because of the COVID pandemic, but just in general. Moisture control, right? You'd all agree is kind of paramount.
Yes.
Kind of a paramount issue of indoor air quality.
Oh, wait, I did miss my opportunity. So as part of the COVID thing, reduce your chemical load, right? Because think we need to sterilize all day long. And the reality is that does not help a lot when you have higher humidity and other factors. So ventilate, open the windows when you're doing all these chemicals, which you really don't need. Soap and water does it. So yeah, there you go.
Yeah, we've been. I will say a shout out to my wife who turned me very chemical green probably 4 or 5 years ago. We just pretty much use vinegar and essential oils. We got away from all those household cleaners, and now when I walk into a space and somebody's using one, I literally start choking. I mean, I can't handle those bathroom cleaners and things like that anymore. It's like, you don't need it.
Chemically sensitive. You're now chemically sensitive. Yeah.
You don't need it. Anyway, well, with that, we're going to be closing off here. Just want to give you guys all a reminder. If you're watching the show, you already know where healthyindoors.com is, probably, unless you're watching us on Facebook. We had like 2,500 on Facebook last week. So, but in any event, we're at healthyindoors.com. When you get there, there's a tab for the HI show. That's the Healthy Indoors show. That'll get you to the current stream every week, Thursday from 1 to 2 p.m. Eastern Standard Time. And it'll also get you to the recordings. We've only been going live since mid-March. We started doing this as a live weekly show. And we really appreciate all the support we've received from our online audiences. We also started that podcast a couple weeks ago. So we put recordings from this show up there, so they're available while you're driving around in your busy commutes during your quarantine. You can actually listen to us in the podcast. Just put it up there. So anyway, with that. Oh, and Healthy Indoors Magazine. Yeah, duh. Okay, that kind of the whole basis of this thing. So Healthy Indoors, just a reminder, monthly free online publication worldwide. You can get it for free. You don't have to pay for it. You can sign up for free at healthyindoors.com. So it's like all there. It's a repository of information. And also, I got a plug for Joe because he didn't plug himself. Hayward Score. Check it out. Online scoring tool. It's also a free tool that everybody should be using to at least do a self-evaluation of your space. It's a good thing.
Thank you. Thank you, Bob.
All right. With that, Nikki, thanks so much for joining us this week.
Awesome job, Nikki.
Thank you.
Joe, thanks for staying awake. We got to push on with this home performance conference that's online for days more.
Well, thanks to everybody who tuned in and been supporting us. A lot of people have been commenting and quoting us. That's amazing. Yeah, to be quoted.
Yeah. At that conference, the live online conference, there's like 1,400 people over at the BPA conference online, and yeah, we've been getting a lot of comments about the show. So thanks everybody.
Well, I did a recorded presentation also for the show.
There you go.
I'm not sure when they're gonna make those recorded ones.
Those are going to come out mid-May. They're going to open
okay.
up their online on-demand system, and because it's getting the whole learning module system and everybody authenticated so they can get credits. But yeah,
Perfect.
anyway, it's a cool
All right.
event. So with that, I'm Bob Krell for the Healthy Indoors Show and Healthy Indoors Magazine. We'll see you guys soon. Stay safe.